Let's try another practice problem. In this problem, we're going to begin with the solution from the previous one. And now we have $1,000 to invest in the two stocks and/or a risk-free asset that yields 1%. We want to find the amount that we should put into each of those three assets to get an expected return of 7% on the entire portfolio, while of course minimizing risk. So let's set this problem up by moving the variance-covariance matrix out of the way a bit. And we know that we'll have a risk-free portion in our portfolio, some Kellogg stock, and some ExxonMobil stock. Some of those may be zero, but let's see. We can measure that in terms of percentage of the portfolio and in terms of dollars. And the answer is going to be here, so let's format that as output. Now we can get 7% on our portfolio in two different ways. Let's come down to the chart and look at that. 7% return on the portfolio can come by investing in the two stocks at a little bit more than 60% in Kellogg. And let's just find out what that would be right now. If I copy this portfolio down and call it a 7% return and do a goal seek to set its return equal to 7% by changing the amount that we put into Kellogg. Remember, the amount going into Exxon is 1 minus that. Then a 65-35 split gives us a 7% rate of return, and that's right here. Another way we could do that is to come over to the capital market line and try to hit this point. It would give us a 7% return at a lower risk. So let's see if we can do that. Capital market line is drawn right now by these 3 points. So let's draw another one and call it solution. And we know that the risk is going to be somewhere between 10 and 15, and the return is going to be at 7. We already have a formula for return. Let's get rid of some of those decimal places. This formula for return uses the rise over run concept and says that if we start at the risk-free rate and rise by the Sharpe ratio times the risk, then we'll get to the point on the chart that we want to be. We used it for the extrapolation to get this point. We want to use it now to get this point. So again, we're going to have risk-free rate plus the Sharpe ratio times the risk of this new point. So let's use that formula, and let's just assume a risk in there of about 11%. Now let's add that point to the chart just by clicking on the line and pulling down the X and Y ranges. Now we have this gray point on the chart. As you can see, when I hover over it, it's at 0.11 risk and 6% return. So we just need to know where that point would be in order to get a 7% return. We could goal seek that and we'd know the risk and the return, but we wouldn't know the makeup of the portfolio. The whole purpose of the problem is to find out what combination of these three assets would give us the correct risk and return to achieve the 7% portfolio return. So let's write these in terms of these. We already have the expected return extrapolated from the risk-free rate using this extrapolation equation. And we've guessed the 11%. Let's write the 11% in terms of these three percentages. So first let's talk about these three percentages. If we put a quarter of our money into the risk-free asset, then that means that we have 1 minus that percentage left to put into the other two assets. And of that, we already know from the optimum risk portfolio that this much goes into Kellogg and that the rest goes into ExxonMobil. So I'll copy that formula after I hit return, paste it in here, and move this to ExxonMobil. So if we were to put 25% into the risk-free asset, then this proportion needs to be exactly this proportion, because we know that tangent point is the best way to mix those two stocks. And we hope that we add those three up and get to 100. Let's alt equals. And we do, in fact. So now we need to write the 11% risk in terms of these three assets. We know that it's going to be the weighted average risk and weighted average return, in fact, between the risk-free and the optimum risk portfolio, because it's just moving along that line. If that point were at 100% in the risk-free asset, then the risk would look exactly like the risk-free asset. If it were 100% in the optimum risk portfolio, then the risk would be 18.5. If it were halfway in between, the risk would be 9.25, or half of that number. So let's take this as the percentage that's in stocks, which is 1 minus the percent that's in the risk-free asset, times the risk of the optimum portfolio. I was pointing up here to 18.5, but let's just grab it right there. And this says if we put 25% into the risk-free asset, then the risk would be higher, the return would be higher, our gray point moved up. Let's just test this. Let's put it about halfway in between. So if we came down here and put 75% into the risk-free asset, it would move this point down 3/4 of the way from the tangent point toward the risk-free asset. So we know we want less money in the risk-free asset. We could put 60% and move that point up here. Let's use GoalSeek to move that point to the 7% return. In other words, get this to 7% by changing this. So GoalSeek to set L22 to 7% by changing the amount going into the risk-free asset. Now we've achieved the desired return at a lower risk than we would have gotten by coming up here and just put it into the two stocks, 13 being lower than 14.2, this being our 13% risk, this being our 14.2% risk, although both of them were a 7% return. Let's just double check and check the percentage of Kellogg as a percentage of Kellogg and ExxonMobil. And it is in fact 36%, 37%. And then if we do the same for ExxonMobil, and they add to 100, we've maintained the same percentage that we said gave us the optimum risk of those two stocks, but we've only put about 70% of our money into stocks and about 30% of our money into the risk-free asset to achieve the desired results. So let's apply those percentages to the $1,000 that we have to invest. And now we have the answers.